Also, have you guys ever discussed flat Earth on your show before?
To some extent.
Yeah, to some extent, yes, we have. But I have to be honest. I've got an open mind, but I want the expert to explain all of it. So that's why
don't have it so open so your mind falls out. Verify everything.
Yep.
But have you had any guests on presenting flat Earth or presenting globe Earth?
No.
Okay, cool.
So this is all you. So you can,
all right.
I want to hear. I've got an open mind. I want to hear.
All right, cool.
So. All right, we're going to get right into it today. We're not going to waste any time on any long intros or anything like that. I'm Johnny Anderson. I'm joined today by Marty Foster, and we have a very special guest joining us today to discuss Flat Earth. That is Flat Earth Dave. Dave, it is great to have you on the podcast, and we have a lot of our listeners that are looking forward to this today. So without further ado, please, sir, get right into it. Let's hear it.
I appreciate you having me on, and I stand from the position that everything that we see, everything that we sense, tells us that we're on a level, non-rotating plane. Government documents from NASA to not that we should believe NASA, the FAA, they talk about all engineering. It says they treat the Earth as a flat, non-rotating plane. All pilots treat the Earth as a flat, non-rotating plane. Otherwise, everybody would die. The science of water, large bodies of water at rest, lie flat. And if the Earth was a ball, there would be a physical horizon at a specific distance based on the diameter of the ball. And we can see far, 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 far beyond that, which is impossible. And the other thing is the Earth measures flat. The heliocentric globe, which is made up by the Big Bang, nothing exploded, became everything, and then turned into balls, perfect orbits. That's the evidence of the ball, which is non-evidence. The point I was making there is all of the measurements that the heliocentric system is based on are made up. They're literally assumed measurements. So let's throw it back to you guys. Why don't you hit me with some questions and we can see where the conversation goes.
Okay. Do you want to start, Marty? You go ahead.
Yeah, just on the point about the horizon.
Yes.
I've spent 12 years at sea, at sea. And depending on where on the ship I'm situated, whether I'm on 2 deck, which is about, let's say, 15 feet above sea level, the horizon is at a certain distance. And if I'm up on O1 or O2 deck, I'm looking much, much further. And this is important at sea for navigation purposes, as well as calling out visual target indications, because I was in the Royal Navy.
100%.
So to me, the higher up you go from sea level, the further away the horizon becomes. Which
that's true.
Tends to suggest that you've got a bit of a point. But
let's address that. Is that the end of your question? Before you go on to something else, we can address that, or you want to finish your point?
Sure. No. Please carry on, Dave.
So put yourself. Are you guys in the United States or where are you?
Marty's in the UK and I'm in Germany.
All right. Well, we have. I always use the example of a Home Depot. I don't know if you have Home Depot. It's just a large department store, whatever, Costco, whatever you have there.
Yeah.
Go to what it look a little crazy. Go to one end of the long floor and lay down. Put your ear on the floor and look across the floor, and you will see a horizon at a very close distance. And then as you stand up and lift your head higher and higher, you'll be able to start resolving things farther and farther in the distance. If I put a whole bunch of bricks or just objects, marbles on the floor, going farther and farther away, when I'm laying down the floor, I can only see a couple of them, and I won't be able to see the other ones because they'll be beyond my visual angular ability to resolve an item. So the higher I get my head up, the better of an angle I have, and I could see things in the distance, which also leads to why ships disappear from the bottom up as they go into the distance. So the higher you are on a, they teach you that on a globe, the higher you are, the farther you can see over the curve. That's cool, but they also tell you the curve is so far away that you can't see it. Even, Neil deGrasse Tyson, the high priest of scientism, says that 120,000 feet you can't see it. They used to say you can see it from an airplane. Then they'd say, well, you have to be on a fighter jet at 70,000 feet. Then they say you have to be, now they say that you can't see it as the height that we can get a balloon to, which is 120,000 feet, 127,000 feet. The only time you see curvature is when they use a fisheye lens. So I sailed across the ocean. I actually windsurfed across the ocean from Newfoundland, Canada to Weymouth, England. And when we're on our ship, we had a ship, a Russian icebreaker. And when I'm up high, man, I could see farther. And I swear, I wasn't a flat earther back then. I could see the curvature of the earth. The reason is, no matter what height you are, let's say the condition, though the sea is smooth, there's no waves, it's the same conditions from your left shoulder to your right shoulder. I'm looking straight forward at 12 o'clock. Let's say I can see 10 miles or 100 miles. I don't care. Whatever that distance is, that point where the sky meets the ground, that's not the curve of the earth blocking the sky. That's just the angular resolution. That's where perspective comes together and causes what we call our horizontal eye zone, the horizon, right? And so that whatever distance that is in front of me at 1 o'clock, 2 o'clock, 3 o'clock, all the way around, it's the same distance. Now, if I put points at all of those times and I connected them, I'm drawing a big circle, like putting my head in the middle of a hula hoop and bringing it up to my eye level. That edge of the hula hoop is my horizon, and it's circular. It's circular. It's just the limit of my vision. Now, that would be the same on a globe and a flat earth. It doesn't prove either, but it does prove that we see in a circle. I'm just going to go here for the people that are listening now and the people that are tuning out because you're talking about stupid flat earth. I offer 3 big points for 1 globe proof. Go ahead. You want to say something?
I'm curious about one thing. So the principle that you're describing, this is the same concept as it would be, for example, I spoke a few days ago, yesterday actually, about I'm sorry, it was 3 days ago on this podcast about how it works across the horizon. So when you're looking at a distance, so for example, here they have one of the largest test tracks in the world for Volkswagen, the car manufacturer.
Yep.
And the straight stretch that they have on it is 10 kilometers long. And you cannot see to the other end of it because it has to take into account the curvature of the earth. So you can only see to the horizon of that.
That's what you think.
You're saying that it's the same concept.
Yeah, the road gets the angular size of the road gets too narrow for you to even see the road. Like if you look at a bunch of street lights, the one over your head is high up, but the one a quarter mile down the road looks like it's touching the horizon, and the one a mile down the road you can't even see. 10 miles, there's no chance you can see it. You see one of the lights, and that just has to do. Yeah, that just has to do with the way that we see. And now the next thing you're going to come to, and it's where I came to because I was you guys, 10 years ago, was what about the sun setting over the ocean? And what you don't understand is, imagine yourself in. I'm in New York City, or you're in a city in the middle, you got 50, 70-story buildings on both sides of the street, and you're standing there and it's noon, and you can look up and see the sun directly above you, but slightly in front of you, high up, is the top of a 50-story building. And then the sun moves 12, 1 o'clock. 1 o'clock, it goes beyond the building. You can't see it anymore because the building's in the way. Very simple to understand, right? And so is the sun below the horizon? No, it's not. It's just beyond the building. If I floated up into the air with a balloon or whatever, I'd be able to see the sun. Or if I walk backwards a couple of miles, not even a couple miles, 100 yards, but let's say I go back 20 miles, I'll see the sun high up in the sky, and the top of that building will look like it's at my eye level from that distance. From a much closer distance, it'll look like it's at my eye level. But 20 miles away, all the tops of the buildings will look like they're at my eye level. Now, whether the earth is a globe or flat, it doesn't matter. Those buildings are still above my eye level. If it was a globe at 20 miles, there's 400 feet of curvature or whatever it is, 40 feet of curvature. Whatever it is, it's not as tall as the buildings, right? The buildings are still above my eye level, but they look like they're at my eye level. And then you have the atmospheric deck of opacity, I call it. Imagine a cloud deck. The clouds that are above your head are 5,000, 10,000 feet above your head, but 20 miles away, they look like they're merging into the horizon. They're not going over the curve. They're just prospectively being pressed into your horizontal eye zone. The sun is celestial, and it's above that, and it just goes beyond it. Just like the sun went beyond the building, It's going beyond that horizon, that horizontal eye zone, which is not at your eye level. It appears to be at your eye level, but it's thousands and thousands of feet above your eye level. And it just goes beyond it, like it went beyond the building. Just for you that are listening, just let me finish what I was saying before. 3 Bitcoins for 1 globe proof. Listen to this podcast. Go to my website, flatearthdave.com, and contact me there. I have an app that has all the frequently asked questions on it. On the app, in the frequently asked questions page, there's a where does the sun go? And there's a boats over the horizon section. Watch those videos. Those are videos that Google will never serve to you. They're on YouTube, but you can't find them. Even if you search for them by their exact name, they hide them and they'll feed you propaganda videos instead. That's weird, right? We all trust the government, right? I assume you guys trust the government, right?
No, oh no,
No.
Of course not. Of course not. Nobody trusts the government, but they're hiding all of the truth videos. So that alone should make you want to look into this. And, I kind of put the Bitcoin incentive back there. And let me just warn you, if you don't want to become a flat earther, don't take my challenge, because that's how everyone becomes a flat earther. Like, I'm going to win these Bitcoins. I'm going to prove the earth is a globe. I'm going to smash all these flat tards. And, you can't, because once you see it, you can't unsee it. I was just on the Roseanne Barr podcast. You know who Roseanne Barr is?
Yeah.
So check out her. She's on Rumble, on YouTube. Check out her latest podcast as the date of this recording. And I'm on there. Watch it. It was really good. We had a great conversation. And it's mind-blowing, and it's waking up a lot of people. So I encourage people, watch that. Hey, flat earth, everyone has the same reaction. It's so stupid. It's so dumb. But now that I've kind of explained the horizon, why we can see farther, let me just explain one more thing. If the earth is a globe, at a certain distance, there should be a physical horizon, and anything beyond that should start going beyond the horizon. That is the globe belief. So do you know what the curvature on do you know what the radius of the globe Earth is?
Well,
it's just under 4,000 miles. It's just less than 4,000 miles. That's what 4, they tell us.
4,000 miles.
Yeah, and the circumference. You know the circumference?
24,500 miles.
Very good. 24,000. Yeah, 24,900, whatever it is. Perfect. Yeah. And so at that distance, at 10 miles, do you know what the curvature should be? Just at 10 miles.
Didn't you mention it earlier? 40 feet, something
like
that?
At 10 miles, it's 66 feet. 10 miles. Guess what? At 3 miles, it's 6 feet. So a 6 foot tall person is standing at the edge of perfectly calm water. They should not be able to see the surface of the water beyond 3 miles, right? And at 10 miles, there should be 66 feet of curvature minus their 6 feet. So everything should be, anything that's 60 feet tall at 10 miles should be not visible. It has to be taller for it to peak up over the horizon. But not only can we see things at that distance, we can see the surface of the water beyond that. And we have done laser tests over water, 26 miles. We have infrared where we're seeing way, way, way beyond that. We have situations where we can see mountains that should be, the top of the mountain should be 50 miles below the curve of the earth. But we can see all the mountains. They're all there, lined up at that horizon right there. So this is impossible on a globe.
Right, we need to discuss a little bit about what light is and how it behaves.
Sure.
Because everything that you've said so far is talking about within atmosphere and talking about light within the spectrum that we understand it. Let me ask you a question, Dave. How, when you're looking at the night sky, do you tell the difference between a planet and a star?
Yeah, that's a great question. How do you tell the difference? The planets used to be called wandering stars.
The difference is really simple, actually. How to tell the difference?
The flickering.
A star twinkles. Twinkle, twinkle, little star.
Yeah.
Anything that has got a solid physical presence rather than just a ball of energy doesn't twinkle the way in which stars do. It's because that's reflected light, and it's behaving in a very similar way to the way light does inside Earth's atmosphere.
Yeah.
So that's the first thing. So
one thing at a time. I can address that, or you have something you want to say?
No, please.
Yeah. So
just what?
Go ahead. I'm sorry for interrupting.
No, I was trying to let you carry on. My bad.
Yeah, listen, I could talk and not let you guys talk the whole time, which I try not to do because I want to hear from you guys. So the whole twinkling thing, I don't know. I don't necessarily agree with that. I mean, if you look at, we have close-ups of stars that we can zoom in on them, and they're these cymatic patterns of energy, and they all have their own little personality. It's crazy. Again, on the app, click the stars section on the FAQ page, and it'll blow your mind what we can see with today's consumer optics. But do you know what the inverse square law of light is? It's very simple. It is saying that every time you half the distance to a light, it's 4 times brighter. Or every time you double the distance to a light, it's 1/4 of the brightness. So also, the angular size follows the same rule. The size of something, every time you double the distance, it's 1/4 of the size. So when we look at a planet, let's look at Jupiter. Jupiter is about 400 million miles away from the sun, they tell us, and we're just under 100 million miles away. So we're 1/4 of the distance. So we look at the sun, right? Imagine if the sun was a mile over our head; it would just fill the entire sky because it's so gigantic. You know, it's a yoga ball, we're a BB, and it's
we couldn't survive.
No, I'm just talking about size analysis. I'm just talking about so. If the sun was just close to the Earth, where the sun is like a yoga ball, we're a BB, it's a millimeter above us, you'd look up, the entire sky would be the sun. So you move it 93 million miles away, and it's now the size of a coin held at arm's length. That's how we see the world. So if I was on Jupiter, which is 400 million miles farther, but about 4 times farther, just over, first, if I doubled the distance of the sun to 200 million miles, it's now 1/4 of the size. I double it again, it's now 1/16 of the size. So that's, like a large star. And a dimmer, 1/64 of the brightness. If I was on Jupiter, which is gassy, non-reflective, and it's looking at that sun, it's a small, tiny 1/64 the size, 1/64 the brightness.
I'd have to disagree with you, Dave. I have to disagree because those observations you're making are as we observe light within atmosphere.
This is from NASA. NASA talks about this. I mean, it doesn't matter whether it's atmosphere or not. And listen, through atmosphere, I could show you that the sun's light will just stop. It will not even push through the atmosphere. We're going to let it push all the way, but light spreads out. Think about this. If I had a balloon and I just put a little bit of air in it, let's assume the surface of the balloon is the light. And if I blew it up to 1 foot wide, it's now thinner. And if I blew it up to 10 feet wide, it's super thin. If I blew it up to 100 feet wide, would you even be able to see the balloon anymore? And that's because the light is spreading out. Light doesn't go like a laser beam. And laser beams, by the way, do spread out. It's spreading out at an inverse square rate. So light in space, it's fine. That's the inverse square law. You want to put the inverse square law in an atmosphere, it's far worse. But you have to believe that tiny little sun is somehow reflecting off of those gassy clouds, even if the sun was the same size that we see it, even if it was, right? It's reflecting off those clouds, which are non-reflective. Clouds usually absorb light, and then it's going all the way back to Earth. And if you look up and see Jupiter in the sky, it's the brightest thing in the sky other than the moon, right? That doesn't make any sense. It makes no sense at all.
Well, it does to me, but only because my grandfather wasn't a university qualified physicist, but he was a man with a lot of time on his hands and did a lot of thinking. And right at the time when I was learning how to be a weapons engineer in the Navy, learning electronics, learning semiconductor theory, learning how components work and all those kind of things, when I'd go home on leave, he'd tell me stories. He'd try and convince me that most of what my learning is based on is actually a lie, which is kind of what you're saying.
It is.
So this is why I first of all asked the question about stars twinkling and about planets not twinkling, because it's reflected energy, which means it's been modulated. I don't believe light travels as in particulate form. It basically regenerates from our nearest source of energy, the sun, across a dielectric of space and reappears just in the same way as an AC current will pass across a capacitor, yeah, but a DC current won't. And it's been modulated. So whatever the frequency, whatever part of the spectrum, which we probably can't even measure still at the sun, that frequency has modulated by the time it gets to us. And it's kind of unique. So therefore, the way in which we observe light within Earth atmosphere, and that goes all the way up to what's the highest level? You'll know because I don't. Stratosphere.
Troposphere, I think is the, or ionosphere is the
troposphere. Yeah,
troposphere. It's one,
the top
one of those.
It behaves in that way inside atmosphere, but you cannot observe light as we know it and talk about light as we know it anywhere outside of the physical presence, outside of atmosphere.
Do you believe that things get smaller in the distance due to perspective?
To some extent, perspective. I mean, when we see it in 2 dimensions, artists use perspective all the time to create that illusion, don't
Talk
they?
about physical reality. Physical reality. If I had a ball,
the object itself doesn't change.
It doesn't change, but our angular view of it gets smaller.
Yeah,
yes,
I can
that's true.
totally accept that.
So do you know about scaling and variance, where they say the sun is 400 times bigger than the moon, but it's also 400 times farther. Therefore, they look like they're the same size, right? You understand that concept?
Yeah.
Okay.
I can.
So they tell us that Polaris is 46 times bigger than the sun. All right. So now we have something to work with, right? So the sun is 93 million miles away, and so for the sun to be the size that it's 93 million miles away. It's 8 light minutes, right? You guys are familiar with that, right? It takes light 8 minutes to get from the sun to Earth.
Yeah, 8 minutes to get here. That's true.
That's what they tell us. And so if I double the distance of the sun, it's a quarter of the size. And now it's, and if I doubled that, it's now 4 times farther. It's a 64th of the size. And if I doubled that again, it's now as small as a star at best. That's a light hour. 8 times 8, 64. We'll just call it a light hour, right? So at a light hour away, the sun would appear the size of a star. But let's be really safe. Let's make it a day, 24 times farther. At a light day away, science, actual measurable science, and understanding how our eyes work, we could not see the sun because its angular size is too small at 1 light day away. So if we had Polaris, and it's 46 times bigger, so we make it 46 light days away. Let's be safe. Let's be fair to the globe. We'll round up 2 light months away. If it was 2 light months away, you could prove that it would be unseeable. Forgetting the brightness issue, just the angular size at 2 light months away would be impossible. Round up to a light year. We'll call it a light year. We'll just give it every benefit of making it so ridiculous. Right? At a light year, but they tell us it's 340 light years away.
I think you're missing my point.
I'm sorry, 430 light years away.
Yeah, I think you're missing my point. You're talking about how it would appear in terms of an object in the sky that we can currently see. So, like you say, I totally agree. It appears to be the size of a coin. Yeah, from our perspective. Yeah, the sun. Okay, so let's head to Jupiter, 400 million miles further, or however many.
Yep.
We don't know exactly what it would look like on Jupiter. However,
what do you mean we don't know what it would look like on Jupiter?
We don't know, as in what the sun might appear as on Jupiter. We can make those calculations and make those assumptions, but they're still assumptions.
Well, I mean,
do you remember the?
Let me just interrupt 1 second. You're making an assumption that Jupiter is a round ball based on assumptions.
Well, there's observable assumptions that we can make. Do you know how ball bearings are made, for instance?
Not particularly, but go ahead.
Right. Have you ever heard of drop forging?
Yeah.
Right. So you have a big tower at the top, you've got your molten metal, and the ball is allowed to drop and turn into a sphere because it's cooled on its way down. So
Sure.
the natural thing to rain, for instance, the shape of a raindrop, everyone draws it as a tear.
Yeah.
But if the rain has fallen far enough in dead air, it's a sphere.
Right. But here's the problem with that. You're talking about surface tension. Drop a gallon of water or a gallon of molten metal from any height, it doesn't turn into a sphere. Now drop a million gallons, 100 trillion gallons. It doesn't turn into a sphere.
It's the scale of the thing, isn't it?
Well,
So
no, you're just talking. You're
if
talking drops. Drops have surface tension. We understand surface tension. It has to do with electrostatics, right? But anything bigger than that, that's when I said large bodies of water at rest, not a drop of water, not even a cup of water, but a tub of water is flat.
And okay. If we're looking at a global scale, not a global, a galactic scale, we're talking about dropping sufficient distance, regardless of the size of the droplet, for the droplet to eventually form into a sphere or an oblate spheroid, depending on what part of the process it's in. So there's the other thing. Properties of a gyro. We use gyros all the time.
Before we switch to gyros, you're talking about drops of water. I don't think that stars and planets are nearly the size of drops of water. They're different in the heliocentric model. So I don't understand the relationship of what you just tried to explain.
Well, okay. If we go from Big Bang, the
nothing exploded, became everything.
The singularity,
made up by a Jesuit priest, not a scientist. Go ahead.
Well, maybe, but we've got current scientists who I don't necessarily agree with everything they say, who are saying that this theory, and a theory nowadays in scientific terms doesn't just mean it's someone's good idea. It means that they've done experiments to try and prove it as close as they possibly can to a certainty. So it no longer doesn't become a law of physics until that certainty has been proved.
Well, that's not true. But in theory, you're saying what you're saying is true, but that's not how scientism, our current science, which is really scientism, works. They make up shit and they claim it as true, and if anyone challenges it, they lose their funding.
But you didn't challenge. We totally agree on that point.
Yeah.
But you didn't challenge me when I said that light doesn't travel in particulate terms. So that's how it's taught. We're taught about photons. We're taught that light travels from the sun to Earth's atmosphere, and we observe it.
And do you believe that?
Spectrum.
Do you believe it travels in photons?
No, because my grandfather had a much better explanation, which was that it actually regenerates from point A to point B. It's stimulated wherever the physical presence is.
Cool. I get it. I have a question for you though. So let's say we have a star, a circle of light, a ball of light, and you're standing right next to it, and the brightness of that entire circumference is X. We'll just call it 100, whatever, just for a number.
Where are you observing it from?
From right next to it. Just I can see the whole thing. I'm standing right next to it.
You wouldn't see it. You wouldn't see it.
What do you mean?
You wouldn't see it. There would be nothing to see. Do you remember the Hubble telescope?
Yeah.
Right. Billions of US taxpayers' dollars.
Yeah.
Up in something that basically didn't work. What was the excuse that NASA gave? Oh, the lens had been ground to the wrong angle. And then there was successive missions to replace the lens. The first photographs, and I'm using air quotes because they weren't photographs, they were pictures within the RF spectrum. And it was basically just an antenna, not anything to do with light. So they weren't photographs, were just made up stuff that they managed to capture and that might, and then they turned it into this is what it might look like.
So,
yeah?
so
when you're next to this star that you were talking about, you wouldn't see anything if you were able to withstand the radiation from that energy source.
I'm not talking
you
about.
wouldn't see a
I'm
thing.
talking about when I say standing right next to it. I'm just talking about how the energy would go. Like if the star had 100 units of brightness or 100 units of energy, right? And you're right next to it. Okay, let's say I'm in a world that's right next to it. Okay, and I could see it in the sky. Whatever right next to it means, just close by. And now we expand my world to 1 trillion miles away. 1 trillion. Okay.
Yeah.
And so, and then now think of that circle. I have to draw a circle around that star that's 1 trillion miles from all points on that sphere to that star. That star has to radiate the same brightness all on the surface of that sphere. So for somehow the brightness of that star, the energy of that star has to multiply and not get diluted. When I yell down the hall, in a field, my voice spreads out and eventually you can't hear it. Light does the same thing. But you're saying no matter how big that expanding sphere of vision gets, the star will always appear in all places along that sphere at the same brightness, which is an impossibility.
No, I'm not saying that at all. I'm not. Sorry, hang on.
All right.
Go on. I'm not saying that at all. Of course, there will be diminishing returns.
Yeah.
The further away you are,
right,
the less the intense
correct.
The radiation is
right.
getting.
So,
that's all due to the amount of dielectric of space
right.
that energy is traveled through, and therefore it's modulated. Do you understand about radio frequency, how we change frequency so that we can receive different things?
Yeah, absolutely.
On different, yeah. So it's a network of capacitors and inductors. Nowadays it's all digitalized and it's all done on a piece of silicon, but essentially it's ways of changing amplitude and of the wave, and then the frequency. So the frequency changes and it lessens, because if we were exposed to how intense it is at its origin, we'd burn up in seconds. It's the physical presence of Earth and other planets and moons and asteroids that allow them to reflect light because they've got physical presence.
Let me ask you a question, and then we'll go over to the back to the
we're going to have to, because of time constraints. I'm sorry to interrupt. Because of time constraints, and I know that you're on schedule as well. There are other topics.
I can go a little bit longer, but just real quick. So I'm 1 trillion miles, 100 trillion miles away from a star. All right, my planet. Now just put a quadrillion other planets at the same distance from that sun, from that light. All of them will be able to see that light at the same brightness. That doesn't work. It doesn't work even in the way you explain light. It doesn't work because that light would have to be hundreds of trillions of times more bright and more energy to be visible at that brightness in all of those places. Moving along, because that's the conversation we could have for hours, and it's a great conversation.
We could. There's one direction I would particularly like to go, if you don't mind.
Yeah, go ahead.
Because I don't want to gloss over it. I've heard you talk about this on other shows before, and I really want you to get into it here.
Sure.
And especially since Marty's here, and he's actually been circumnavigating the globe.
Yes.
So I want to hear. I want to hear your point on every direction that we travel. You're always going south.
Yeah.
I have to hear this.
Yeah. So it's very very simple. Were you done? I'm sorry, Johnny.
Yeah. Go. Yeah. Go ahead. We're going to have to move on. I'm sorry.
Yeah, no problem. We'll talk about circumnavigation. Circumnavigation is very easy, and circumnavigation is we know we're circumnavigating because we're using a compass, right? And you guys have all seen the flat Earth map, the Gleason's map. That's the best map that we have.
Yes.
and that
Yeah,
we
I've seen
believe
it.
that the sun circles around. So you get a Gleason's map, put it down on your table, and get a nice strong neodymium magnet, slap it down the center. That's the North Pole. Put a compass down anywhere on that map, and the compass needle will point to the north, right? And so now I can push that compass, which is a boat or an airplane, west. And to maintain a western direction, I have to constantly turn to the right. Otherwise, I'll be heading south, because south is every direction away from the magnet. The magnet is the north. So if you and I were at the North Pole and we had our backs to each other and we both started walking away, we'd both be walking south, because south is the opposite of north, right? East and west are circles around the North Pole. So let me finish. This is going to be good, right? So when you're going west, you have to turn to the right. And when you're going east, you have to turn to the left. And if you maintain that heading of 270 or 90, you will end up right back where you started from. And you'll say, I circumnavigated the Earth. How is that possible if it's flat? Well, I just showed you how it's possible. Here's the thing. Billions and billions and billions of people have circumnavigated east and west. 0 have done it south. Now, you can make up excuses, go, well, we're not allowed to go over Antarctica. Nobody has circumnavigated the Earth south. You know why? It's impossible to do on a flat Earth. It's very possible on a globe, if a globe was even possible. So that's how circumnavigation works. But here's the thing. In the north, on a globe or a flat Earth, it's the same. You would have to turn to the right. You'd have to turn to the right when you're heading west. If you were on a globe and you're 1 mile from the North Pole and you wanted to go west, 6.28 miles later, you'd be right back where you started from, because you went in a circle around the North Pole. That's the same on a flat Earth. It doesn't prove either. Here's the problem. When you get south of the equator on a globe, when you're going west, instead of correcting your direction to the right, you'd have to start correcting it to the left. But we have military ship captains that say when they're dead reckoning east or west in the Southern Oceans, they constantly have to correct to the north. That is some really good evidence for a flat Earth. But isn't it weird that nobody has circumnavigated south? And the couple of stories that the ones that say they have, like there was a Pan Am flight and they showed all the points plotted out on a flat Earth map. They didn't circumnavigate anything. They just went in a big circle on a flat Earth.
When 1986, we set sail from Portsmouth, heading west.
Portsmouth, Maine? Portsmouth where?
No, Portsmouth, United Kingdom.
Okay.
The real one.
Heading west. Yes, I got you.
heading west.
Yeah. Towards the United States.
We had a few little stops here and there, but our first hit was Miami.
Okay.
After Miami, we continued to head west through Suez. Sorry, not Suez, through Panama.
The Panama Canal,
Panama.
yep.
Through Panama.
Yep.
We then carried on into the Pacific, went north up to
Hawaii,
Canada.
Okay.
Yeah, north to Canada.
Yeah.
We then crossed over to Hawaii to do Rim of Pacific exercise.
Yep.
Then we continued on to mainland China, went to Shanghai.
Yep.
Still heading in that westerly direction.
Yep. I'm looking at it on a flat Earth map. It's making perfect.
Yeah. Went down to Australia.
Yep.
Eventually back up through Suez, through the Mediterranean, and back to Portsmouth.
Yep.
I was responsible for changing the settings on a system we have on board ships called degaussing. You're aware of the word Gauss, yeah?
Yeah.
Okay, so the unit of magnetism discovered and researched by Gauss. And we have these coils around a ship, and they are to stop the ship from magnetizing and one deck becoming a magnet and so on. As well as that, it also discourages magnetic mines, and it helps preserve onboard sensitive equipment. So those settings on the 5 different coils that I used to have to change every so many nautical miles were all laid down with reference to a globe, because basically wherever we were on the globe, you would draw across the lines, find out where you were, and there would be a set of readings or settings to change the degaussing to.
Yeah, this is the same. It's the same on a flat Earth. It's the exact same thing. You're not understanding that, especially in the North. It's exactly the same. The South actually proves it doesn't make any sense when you look at flight routes and the way ships have to constantly correct to the North when they're heading east or west. They should have to correct the other direction. They don't, right? I want you to get a flat Earth map and then draw out your path, and you will see exactly what you did. You just went around. Like if you walked around, if your town hall is at the center of your town and you lived on the outskirts and you walked all the way around the outskirts of your town and you got back to your house, did you circumnavigate a sphere or did you circumnavigate your town? Right? You're circumnavigating on a flat Earth. Why do we have a longitude and latitude, X and Y, system for navigation on a three-dimensional surface? Where's the z-axis? How come a Navy ship with a railgun can target with a pinpoint laser a ship over 100 miles away, which would be well over a mile of curvature? There should be a mile of water, 6,000 plus feet high in between, but they can see the other ship. How come
no, they really can't.
They can. They can.
Trust me.
It's not that trust. We have testimony and proof.
At 100 nautical miles.
Yeah, 100 miles. Yeah.
If the camera that's tracking that surface target would have to be so high that it makes the ship unfeasible.
Wait, hold on. I have to interrupt you there. That's if the Earth was a globe. But you're not understanding with today's optics. Go look it up. The railgun can visually see and target another ship from their ship at over 100 miles. I think it's 115 miles, right? 100 miles.
Not without independent target acquisition by an airborne source.
Incorrect. If the Earth was a globe, you're absolutely right. Submarines on the bottom of the abyssal plain can use their sonar and see another submarine over 100 miles away. That means that sonar wave has to climb over a mountain over 6,000 feet tall, go down the other side, hit the submarine, climb back over the mountain, and then go back down and go back to the sonar radar. That doesn't make any sense.
That's an active sonar.
No, active sonar doesn't climb the curve of the Earth.
No, but towed array passive sonars can.
Yeah.
Because sound travels through the medium of water great distances.
Yeah.
And they have whole libraries, audio libraries of all the ships from around the world. It's a big intelligence gathering operation to gather those noise signatures so that a passive sonar can detect.
Marty, what about microwaves going over 10,000 miles? Microwaves are point-to-point transmissions, 10,000 miles. Now, I know you're going to say they bounce off. What, are you going to deny that they can?
No, they can't. They can go off satellites. Yes,
no, they're point-to-point. They're point-to-point, and they're
10,000 miles.
10,000 miles. Absolutely, we have documents. We have documents.
Well, whoever made those documents,
the government made the documents.
Well,
we don't believe the government.
We don't believe the government, and I work for the government. Indirectly.
I mean, the military, which is the government. You're right, but there's operators that say that they can do that. I mean, there's been radio.
A while ago, once I'd left the service and I was on the tools. We fitted out units of 3 vehicles, different types of vehicles, 432 armored personnel carriers, Land Rovers with trailers, and our Royal Marines BVs, which are the Snowcats. And each set of 3 vehicles could track 2,000 targets simultaneously down to a mobile phone over a very wide area, but they used satellites. It's a satellite uplink. Microwaves cannot travel that far in a straight line. It's why we have different types of communications on board vessels. We have LF, low frequency comms, which is largely for submarines because it can penetrate at long distances under the water. We have VHF, HF, VHF, UHF.
When you say that,
and when you get to UHF, you're into the microwave frequency, and they are very short line of sight transmissions.
So you haven't seen the research that we've done, and you need to look into it. There's a section on my app about satellites, and that's in there, or in Schooling the GLOBES section. There's a whole thing on microwave transmissions, and you could look it up and verify yourself rather than just believing what you were taught. But when you say that these ground-based tanks or whatever that can monitor great wide distances because they're using satellites, let me ask you a question. Could they be using like an airplane, an AWACS plane to bounce their signal off of?
But at the time I built them, no, because it didn't exist. Nowadays it does. You have things called...
You believe that we have little tin cans that are geostationary satellites that are matching the spin, the wobble, the orbit, and the chasing of the sun. 4 different motions at once, and somehow this tin can stays exactly where you want it, hundreds of miles above the Earth. And changing speeds as the Earth changes speeds, and in all the different directions. I'm still talking.
I'll take you back to a question I was going to ask you earlier, Dave.
Yeah.
Properties of a gyro, a spinning body.
Yeah.
The properties of the gyro are rigidity in space.
Absolutely.
So angular momentum, which means lines of force come off of it in all different directions. It's multi-dimensional, because normally the spinning body is a sphere or a cylinder.
But
and then you have precession.
What does a gyro holding rigidity in space mean?
Well, basically, it tries to maintain its spin axis.
Does it?
So, yeah.
Wait, hold on. Let me just finish my line of questioning. So, when you spin up a gyro, it holds its position relative to where it was spun up. Is that correct?
Yep.
So so if I'm in an airplane and I did a loop-de-loop and I turned around and I swerved back and forth, it's going to hold its same orientation to the runway where I took off from?
No, what it does is those pressures precess the gyro. They move it around, but because it is maintaining a constant speed, eventually it will recover its spin axis that it was first set up. What it does by moving around, we use things called accelerometers. They take a feed off the gyro as it's fighting against being moved, and it tells the vehicle that it's in, whether that vehicle's a ship or an aircraft or a spaceship, how it's moving. That's how gyros work for navigation. The use
what about the original gyros that they had on airplanes that just spun up and didn't have all the electronics that you're talking about that are measuring these fictional forces?
But then you had things called, you've got HER and VER, vertical Earth rotation, horizontal Earth rotation. The gyro is adjusted for HER and VER. Otherwise, without those adjustments, it is purely north seeking. But if it's adjusted for Earth's...
it's now north-seeking? I thought it held rigidity in space.
This is what I'm saying. The properties of a modern gyro are rigidity in space, so it will continue on its axis, but it will try to seek north within Earth, if it's on Earth. If it's adjusted for vertical Earth rotation and horizontal Earth rotation, it becomes north finding and therefore becomes an accurate navigation aid.
So when I fly 4,000 miles from one airport to another in a straight line over the curved Earth, which is the curved line, I've now changed the orientation of the plane by 90 degrees. Is the gyro going to rotate 90 degrees so when I land, it's level with the runway that I'm landing on?
No. That's not what gyros are for. Gyros are to point north. It's to tell you where you're heading, where you're heading.
Gyros do not point north. Gyros hold rigidity in space and show you what level is.
But when you adjust them for vertical Earth rotation and horizontal Earth rotation, which
vertical
are calculations,
Earth rotation and horizontal Earth rotation, what are you even talking about? The Earth rotating in 2 different directions?
Well, no, you're basing your theory off of the fact that it's a flat Earth, and Marty's
And I'm
basing his theory off
saying
the fact that
the science
yeah.
for a navigational gyro works on the fact, okay, I'll give you this. It works on the assumption that the Earth is rotating horizontally and vertically.
No, that's not true. The gyro works on the assumption that it holds rigidity in space. So you spin it up level to the airport that you're taking off from, and it shows you.
With the greatest respect, the Royal Navy spent a great deal of money training me to maintain.
Training you, very good.
Training me to maintain navigation systems, weapon guidance systems, and so on, all of which rely on this technology and these physical principles.
You have a lot of beliefs there, my friend. With all respect, you have a lot of unsupported beliefs.
I've got the belief of my own eyes because I've seen it work. Well, it's just the same. It's the same with.
But you said that a gyro won't land vertical. How is that possible?
I didn't say anything of the sort, mate. What I said was that the properties of a gyro are rigidity in space, precession, and angular momentum. So, using those properties, we have turned.
Explain to me how a gyro adjusts when it needs to turn 90 degrees.
When forces are applied to the axis, right? Let's say you've got a jet engine behind the gyro in the middle of an old Cold War fighter. Yeah.
No, I'm talking about on a modern 747.
Okay, so you've still got these forces where the aircraft is maneuvering and trying to turn. Let's say it's going to come into the old Hong Kong airport and it's got to fly between those buildings. It banks round heavy to port and comes in between a load of high-rise buildings. You could wave at the little people in the windows, and while it's doing that, the gyro that's on board that aircraft has got turning forces exerted on its spin axis. But the gyro, having rigidity in space as one of its properties, tries to reassert itself back onto that spin axis. That's how it happens. That's how it works in practice.
Yeah, but not in reality. That's not how it works in reality. I'm sorry. It doesn't work that way in reality.
Is reality.
A gyro is on a 3-axis gimbal, and no matter which way the plane turns, which way gravity's pulling, if you want to believe in gravity, it does not affect the gyro, and the gyro holds its orientation to the original airport. Right? There's 100 ways to prove that, and you're just saying stuff that no globe component has ever even said. I don't want to say you're making up stuff, but you've been trained to say this, but you have zero proof of it.
I've got a huge amount of proof of it because I've done it. I've done it live. You know, I've had one that's broken and I've fixed it applying these principles, and it's worked again. So we're gonna have to agree to disagree on that. But can we get to one of our other contributors' questions?
In one sec. Yeah, in one sec. I have to get him, because we were talking about flights. I have to get him to talk about this last point, and we can probably make this one quick. I've heard you talk before, Dave, about the flights and how the flight times are not what we perceive them to be. Could you please explain that?
What are we talking about here? Exactly.
I've heard about a year ago you did a podcast. I can't remember which one it was, but I remember hearing you last year on one. And you said that the flight time, I believe, and maybe I'm mistaken, but I don't think that I am. I heard you say that the flight times that you take are not as long as we're made to believe. Like the flight lines are actually different than what we were shown.
Well, the distances.
Distances. That's what I mean. Yeah.
Yeah. Not the times. So flying from Santiago to Australia on a flat Earth is a very long distance, and people will say, "Well, I can fly from New York to, Dubai or wherever in the same amount." Excuse me. Same amount.
That's one of the longest flights in the world. So
absolutely. But why is it the longest flight in the world? Because they're very close to each other on a globe. You can just scoot around Antarctica because you don't want to fly over Antarctica because you might disturb the penguins. And it's a very short flight. But in reality, we've had guys on flights with a compass, and their compass is leaving Santiago it showed it was going northwest, and then it was going west, then it was going southwest, and then it was going south. And if you draw a line on a flat Earth map straight from Santiago to Australia to Sydney, those compass readings make perfect sense. Now, the question is, how can that plane get there in 14 hours? Well, the answer is, did you know that every day, twice a day, there's 1,000 balloons, weather balloons, launched from spaces all over the Earth at the exact same time, twice a day? And they send in.
I did not know that. No.
Yeah, this is every day, twice a day. And they go up to all the different altitudes, and they send all their data back to a supercomputer, and it knows exactly where the winds are. At 45,000 feet, there's winds that are 350 miles an hour circling the Earth, right? This is, disclosed documents. And so if you look at the path that that flight would take, it's going with that wind. And so if it was the short distance that they say, that would mean that the plane's flying at like 250 miles an hour and catching the tailwind, or maybe it's flying at 600 miles an hour, catching a 350 mile an hour tailwind. That's almost 1,000 miles an hour land speed, and then it makes perfect sense. Perfect sense. Excuse me. So hold on. Last thing. On the Flat Earth Clock app, there's a Southern Flights section. You can even just pull up Southern Flights in the images, and you'll see these flights that make absolutely no sense. They're ridiculous on a globe, but if you look at them on a flat Earth, they're straight lines.
Because I was flying back from Abu Dhabi to the UK very regularly. It's
straight line.
It's a 7-hour flight, and that can vary to 7.5 to 6.5 hours. And the couple of things that made it different is the direction you're flying. If you're flying on an Etihad aircraft into Abu Dhabi, you get to land first because they're like that. They do play favorites, right?
Marty, it doesn't matter. What I'll just say before we go on and waste time, it's the same on a flat Earth. The globe Earth and the flat Earth in the north, the flights are the same.
Yeah, but forgive me, but what I was trying to do was allude to the fact that in the other direction, you're flying with the Earth's rotation. Therefore, there is a slight difference in time. And where are these winds coming from? Because what you're talking about is the slipstream.
Yeah, no, I'm talking about the toroidal spin of the ether around the Earth, and there's these winds. You can look at these. I have a chart on my app. It shows you the wind speeds at different altitudes in real time. And this isn't a theory. This is the absolute truth. Look at on a flat Earth. They show you these winds that go up in this huge sine wave. They go way up and way down. Chart that out on a flat Earth, and it's a perfect circle. It's weird.
What's causing the wind, Dave? What's causing the wind?
It's the energetic. We live in this toroidal field on the domain block wall. It's the spinning of the toroid. I don't know what makes the sun and the moon circle the Earth. What are the sun and the moon? These are questions that I don't have to answer because I don't know the answer. Right. But the thing is, when you look at Southern flights, when you look at emergency landings that are landing in places that are impossible to get to in the amount of time that they get there, and like, why would they even land there? Right? If you look at these landings, go to my website, flatearthdave.com, scroll down to the emergency landings book and look at some of the flights there. It's absolutely ridiculous on a globe.
Can you give us an example? Can you give us one example of one of these emergency landings you're talking about?
Yeah. Let me pull up one. So there was a flight from hold on. So there was a flight from New York to Hawaii. And halfway through the flight, if you look at the flight path, they tell you they're going over Southern California. They had an emergency, and they landed in Seattle, which was over 1,000 miles out of the way. They landed there in 15 minutes. 1,000 miles in 15
from LA.
Well, that's where they said that they were. But if you look at it on a flat Earth map, you draw a line on a flat Earth map from New York to Hawaii, Seattle is directly under that flight path. Right? Because
there's no curve. Yeah, okay, I got it.
No, it's not because there's no curve. It's because that's where we are. There's a flight from Chicago to Doha, and where it had an emergency and it went 1,500 miles out of the way to Moscow, right? And it got there in like 15, 20 minutes, right? Why did it go to Moscow? And that's because on a flat Earth map, they're flying directly over Moscow, right? When you see these things, there was one where it was a flight from Hong Kong to the UK, and 4 hours. It's a 12-hour flight. 4 hours into the flight, the family was traveling together: mom, dad, the little boy, little girl, and the mother died. She just died in her seat. Died suddenly. Weird, right? And 4 hours into the flight, they didn't land for 8 more hours, right? Could you imagine sitting next to your dead mother for 8 hours, right? Why didn't they land?
No, I can't. I've been on an international flight when someone has died. It's not a very nice thing, and they're in the back of the plane.
I jokingly say, could you imagine sitting next to your mother for 8 hours? All right, but, that's a little joke. All right, and if you look at the flight path that they said they were going on, there was 100 airports they might have been able to land at, but instead they landed at Germany, which is pretty damn close to London. I'm like, after 8 hours, why don't they just finally go to their destination? But if you look at it on a flat Earth map, 4 hours into that flight, they were flying over Russia. And if they landed in Russia, two things would happen. One, Russia would be very helpful, and that could spark world peace. And two, people like me would say, what the hell you landed in Russia for? Look, it's flat. So they couldn't land. They couldn't land. They had to go all the way to Germany before they could land, because that's the next spot that's on their flight route on the globe. So these things, there's video, there's a book called 16 Emergency Landings. You can find it on my website. There's a free PDF online. You don't even have to get the book, and just check it out. But there's been many since that book was published where it happens again and again. You know, the remember the World Cup, right? You guys like the World Cup.
Yeah.
So the World Cup, the World Cup was in Doha, and the team, the Buenos Aires, won. And they have a chartered flight, their own flight. No one else is on the flight, so there's no excuse why they would have to go to another airport other than to refuel. They went to Rome to refuel. Rome is in the wrong direction. It put them farther from Buenos Aires, according to the Globe, right? They refueled in Rome, and then they flew to Buenos Aires. Look at it on a flat Earth map. Rome is an exact straight line to Buenos Aires, an exact straight line.
But there's another reason why they would have headed west to get back to Argentina. Yeah.
Why?
It's because if you go from Doha all the way across Russia, across China, you have to.
On the globe, you're going across Africa. You're going across Africa. You're not going across Russia.
In your opinion?
No, on the globe. On the globe, you don't go across Russia from Doha. Well, if you want to go towards Buenos Aires, you go across Africa.
Okay, so you're going across Africa. Yes, you're right. So I was thinking, going the opposite direction, just taking off and heading east, which would take you over lots of wide open oceans. There's big sections of the sea out that way that are not covered by satellites, and that's why we've had those aircraft go missing.
You're making up excuses. I'm sorry. You're making up excuses. This is a
let me just finish your point.
Well-traveled area. This is a well-traveled area.
Yeah. Let me just finish your point. Aircraft pick their flight, paths, or are told what their flight paths are to be, because every major commercial airline flight has contingencies. Now, they carry enough fuel so that they're not overburdened with fuel, but also so that they are able to divert if necessary. I'm going to have a look at some of these, the ones that you said on the website. But I think in most cases, you'll find that they've diverted to the particular airport because of factors beyond their control. So whether it's an actual mechanical or electronics malfunction, or maybe it's a war zone. For instance, nothing is going over Ukraine and Russia at the moment.
Yeah,
all the flights are being diverted.
Which is interesting. We have a moment to talk about Starlink and why they turned Starlink off over there. But real quick, Auckland, just to debunk what you just said, Auckland to Lima, Peru. Right. And if you look at it on a globe map there, if you draw a line from Auckland to Lima, Peru, it's whatever the distance is. But in reality, the plane goes all the way up to the northern hemisphere to Los Angeles and then all the way back down to Lima, Peru. The open stretch of ocean that they're flying over from Auckland to Los Angeles is longer than from Auckland to Lima, Peru. And then after it gets to Los Angeles, it has to go all the way down back to Lima, Peru. But if you look at it on a flat Earth map, it's a perfectly straight line. Right?
My flights from Miami, which I had to do quite a few times in the 90s.
Yeah, I've flown through Miami. Yeah.
They all head up the east coast of the United States, up to Nova Scotia, and then head across and then come back down again. That's so that they are in contact with land or close enough to land for the longest time before they have to cross a broad stretch of ocean. And I think that's, the simple explanation would be that's why some of these diversions.
You're completely, I'm sorry, respectfully incorrect there. I'm just going to show you. I'm pulling up a picture so you guys can see, right? They went from Auckland, which is right here, right here on the globe. They went over this massive open southern and northern ocean to Los Angeles and then all the way back down to Lima, Peru, right? And this is a shorter distance from Auckland directly to Lima, Peru, but on a flat Earth map, it's a straight line. Okay.
Yeah,
all right.
Good depiction.
There's hundreds of these. You have to take the time and look. You have to be willing to realize that your entire life is a lie. And you
I know my entire life is a lie.
We can all agree on that.
I agree with you there. But Dave, bring that photograph back up again, please, if you can.
Yeah.
You see that bit of ocean with the big question mark in it?
Yeah.
Right. That bit there
yeah.
isn't covered by geostationary satellites.
You'd have to. You're assuming that satellites cover the world. They don't. And you're right. There is no geostationary satellites there, but there's also no geostationary satellites here. Really,
yes, I'm afraid there are.
There's no satellites. Satellites do not exist. Right.
Okay.
Well, hold on a second.
Right.
So
the project that I was paid to create an apprenticeship for a little while ago, and it's still running. It's things called HAPS, high altitude pseudo satellites, and these are a stopgap method of putting a very large drone into between 40 and 70,000 feet, which cover those bits of the ocean that are currently not covered by the satellites that various space agencies around the world apparently haven't put into space. And that sat phone on Johnny's desk doesn't work on satellite, and the satellite communications telephone calls I made from Djibouti in East Africa didn't ever happen because they must have been some other form of telecommunication.
Absolutely. But it is more another form of telecommunication.
All that aside, this is the question. This is the.
Are you familiar with satelloons before you ask me that question?
Satelloons?
Yeah.
Is this a satellite attached to a balloon?
Yeah. There's tens of thousands of them up there. Tens of thousands.
Okay. I have heard this before. Yes. I have heard that.
Yeah, there's tens of thousands. They don't talk about it. 99% of the helium in the world is controlled by NASA, right? And I'm not even claiming that these satellites are how you communicate. There's undersea cables that have been here for hundreds of years, and they're putting more in now. There's none connecting the southern, like from Santiago to Australia. It goes all the way up into the north and then all the way back down. Why didn't they just cut across the Southern Ocean? Is that because there's no satellites out there? You can make up excuse after excuse after excuse, but satellites are not the way it works. The way they use communications, the way Starlink works is they're using airplanes, right? I was on a flight. Where was I going to? I was going to just across the United States. And while on the flight, I was able to download stuff. I was able to upload 3 videos, 300 people on the airplane. They're all uploading and downloading. And that's no problem. All the equipment's on the airplane, right? The airplane's only 5 to 7 miles in the sky, right? Imagine a cell tower 7 miles high, right? That would make up that would cover a great area. So Starlink, all it's doing is it's using airplanes. When the Ukraine war started, first thing Elon Musk says, I'm turning off Starlink in Ukraine. Why? Because there's a no-fly zone over Ukraine, right? You have to watch
But
my
didn't he
videos.
send
What?
didn't he send Starlink systems in there because there was no internet access from land-based communication?
I mean, well,
he
at first
revoked it
said,
later. Yes, you're
yeah,
right.
he revoked it, but because there's no satellite, no planes flying over. The other thing is, you don't know what planes are flying over there. There's planes at 50,000 feet. You can't see them, right? There's all sorts of stuff going on. But you have to believe that a cell tower, if you unplugged it, it wouldn't work. How does a floating tin can around a spinning, twirling, whirling Earth maintain its position and traffic, tons and tons of data, right? How is that even possible, right? It's not possible. But an airplane, which can be serviced, which has power, which they know exactly where it is, right? The Earth is twirling and whirling in 4 different directions at once, and you believe that a satellite can maintain its position, right? And have power. It's not even, how is it even grounded? You haven't looked into this because you've been educated, indoctrinated, and taught us to think there's only one way to do something. You have to unlearn what you've learned.
If I did that, I'd be out of a job. But
that's right,
enough.
And therefore you can't. That's awesome that you said that. Right on my app, if you search peer review and stuff, we have people that are like, there's no way that you can do that. If you challenge any of this stuff, we had a pilot from KLM who came on GlobeBuster show and was telling us how the Earth is flat, absolutely, and proved it, and it was how they fly the airplane and all this stuff. Next day she was grounded, right? Finished, right? All, not some, all of the Qantas pilots out of Australia, they all talk about flat Earth amongst themselves. I have a dozen people, pilots in my phone from American Airlines, from Delta Airlines, from all different airlines. They're all flat. They know it's flat. They know it's flat. They tell us it's flat. And they fly the plane assuming it's flat, right? If you're in Alaska, right? You're moving, if the Earth is spinning, maybe 300 miles an hour around the center. If you flew to Ecuador and wanted to land on a north-south running angled runway, that runway is moving sideways at over 1,000 miles an hour. How the hell are you going to land on it? How are you going to gain that tangential side speed, right? That you didn't have before you took off. Are you going to say gravity does it? You're not thinking this stuff through, because when you do, you have to realize your entire life is a lie, which you say that you're starting to realize, and you're going to lose your career. You're going to lose your career. You're not willing to do that.
I'm willing to do it for other things. I mean, our podcast is mostly geopolitical, and just about everything that I've ever stood for, worked for, believed in has proven to be wrong.
Marty, recently. I believe you're a good guy. I believe that you got a great heart. I believe that you're highly, highly indoctrinated, but I believe that you can see the truth if you want. You might have to keep it to yourself.
Yeah, I can see, right. I can see the truth. But when we started our podcast some time ago, we kept saying they a lot. And it's not because we were self-identifying or using the correct pronouns.
Yeah.
But they do this, they do that. And I insisted that we identify who they were.
Yeah.
And we went through probably 2 hours, 2 separate podcasts to establish just who they are.
Yeah.
And so in your terms, who are they? Who are the ones? Who are the ones? Let me finish the whole question, Dave.
Yep.
Who are the ones that are continuing to promote this? What do they stand to gain? Because you've always got to follow the money.
Yeah.
And the other thing is, and it is linked. Back in the day of the early astronomers, the Catholic Church put people in the Vatican prison for heresy, for saying that, the Earth orbits the sun rather than the sun orbiting the Earth. Yeah. Those that started to develop telescopes started saying, well, that looks round to me, doesn't it, to you? And people, like I tried to talk about earlier on, talking about drop forging, the way a ball bearing forms in a drop.
A drop.
Physical.
We don't live in a something the size of a drop. You have to compare.
Scale it up, Dave. You've asked me to scale it up from trillions and quadrillions.
Yeah, but you can't scale surface tension. Surface tension doesn't.
Yeah,
scale.
you can. A meniscus does. A meniscus does scale.
No, it doesn't.
Right, we're getting off.
Yeah,
we're getting off topic. We're getting off.
But yeah, sorry, Dave.
Yeah.
Who stands to gain?
Yeah.
By feeding us this lie.
So the people that we see, you know, the Rothschilds, the royal family, the Council of Foreign Relations, the Bilderbergs, all of those people, those are the people
usual suspects.
Yeah, those are usual suspects, but they also are getting their marching orders from somebody else, from somewhere else that we don't see. They all go to Antarctica at the weirdest times and disappear for 3 days before they reappear in alleged South Pole Station, and then they go home. Where are they going? Right, there's whistleblowers from the military that say that there's cities of millions of people that live in the outer areas of Antarctica that aren't allowed to communicate with the inner world. I think that there's more land out there. You know, all wars are fought over land, resources, power, right? I think there's more land beyond the shoreline of Antarctica. I think that there's other worlds just thousands of miles away, not billions and trillions and light years and ridiculous distances. None of that makes any sense, right? So if you have a population, if you we're all born into God's world with natural rights. We're inheritors of this realm. We have nobody has rights over us, but they immediately register us, with a birth certificate and trade us on a stock market and treat us as cattle. And then they say, oh, you live on a ball that's spinning through godless space. So if you live on their ball field, you have to play by their ball field rules. And if you play with their fiat money, you're controlled, right? So if you believe that we live in a world where we're running out of food, we're running out of space, we're overpopulated, we're running out of fuel, asteroid could hit us at any moment, solar flare is going to get us, nuclear bombs going to blow us up. Nuclear bombs are fake, by the way. And all of this stuff, if you live in fear, you're never going to reach your full potential. It's not about money. They control us with money. NASA gets $80 million a day. They don't really get $80 million a day. They just take that from us. They tax us. They do all sorts of stuff. And the only way to get away with it is because we believe it to be true. All of that is bull crap. All of it is bull crap. And the only way to get away with it is because we agree. Fear is the only thing to fear. False evidence appearing real. FEAR. That is a fact. And if you understood that you are at the center of creation, that we have in tremendous power and nobody is above us other than God, right? The government wants to be above God. They're already, in most people's minds, above them. Then there's the reason. That's every reason. If people on my app, there's 190,000 people on the Friend Finder right now. All of them unvaxxed, awake, aware, unplugged. They're most amazing people ever, right? They're uncontrollable. A world that is in a situation where they cannot deny creation and they understand their true position as they're uncontrollable. They want us in control. They want us in fear. They want us sick. They want us on their medications. They want us starving to death. They want us living shorter. In Canada, if you're sick and you're like, hey, I need this operation. They're like, oh, sorry, there's no funding for that, but we can assist in your suicide. That's where this world is coming from. It is going to, right? And have you guys ever heard of the Illuminati Covenant?
Dave, take a breath, buddy.
Yeah, no problem. There you go. Thank you. I was ranting.
You would not believe how much we have in common.
Yeah, I do. I see it. You're a good guy.
But there's always a but. I think you're conflating a few things. And what you're actually doing, the argument that you have about this, the deep state, the ultra rich, the so on and so forth, that is a valid argument, but it's immediately torn down and discredited and dismissed because of your other views. And an awful lot of people in recent history who have stood up and said this is wrong. Vaccinations. They're not vaccinations. They're a gene therapy.
Are you vaccinated? I'm gonna ask. You don't have to.
No, I'm not. I'm definitely not.
Good for you.
None of us are. No.
None of us are.
Don't fall for the bird flu either.
And we've seen through it all.
Good we're ready for the bird flu.
We've also got a resident theologian who has a strong faith. I'm not an atheist, by the way, but I don't believe the way you believe.
How do you know what I believe?
Well, you just mentioned God several times.
You believe that the world is came from a Big Bang, or that it was intelligently designed by something?
No, I don't believe that it was intelligently designed by something. I think
Evolution.
my personal well, I believe in evolution, yes, but my personal belief is that the spark of divinity that we see as God is in all of us.
Yes,
and when you get enough people thinking in the right direction, you get some good things happening. When we are disparate and we are all believing different things, and in some cases the same thing but the wrong thing, that's when the bad stuff starts to happen. But we'll part as friends, because you haven't convinced me.
I can see that. Here's what I'm saying for the people that are listening: if you think that Marty's right, come collect your 3 Bitcoins. All you got to do is go to my website, scroll down and see a big picture of me, and it says crash course. Click that, and there's a list of videos. Watch at least 3 of them. I'd say start at the top. Watch the first 3. You'll be highly entertained. That's the worst thing. But actually, it's not the worst thing. The worst thing is after 3 of them, you'll be a flat earther and you'll be rejected by your friends and family. But you'll understand. But if you watch 3 and then come at me with a globe proof, because you can't, it's scientifically impossible to watch those 3 and still believe we live on a globe, right? But these videos are being hidden from you. You'll never find them on your own. Google me, Google flat earth, right? You're going to get propaganda videos. Watch a whole bunch of my videos, other real flat earth videos on YouTube. Go to your history and search flat earth. All of those videos won't show up, and propaganda videos will replace them. What is going on there?
Well, it's the algorithms, clearly.
Forget the algorithm. Your history is being lied. They're lying about. Like I looked up underwater.
I'm not going to argue with. Yeah, I'm not going to argue with the fact they're lying about history. We know that.
No. That's not what I'm saying. I'm saying if I watched the video on how to skin an alligator a year ago, I can go to my history and find that video in my history. I could watch a whole bunch of flat earth videos. I could go to a whole bunch of flat earth videos and watch them over the last week, and then, or whatever, week, year, and then I search my history for flat earth. None of them will show up. Only propaganda videos that I didn't even watch will show up. Okay? What is going on there? Why are they doing that?
They've had a bit of a digital clear out, haven't they? They've been doing some digital spring cleaning.
They've been doing some programming, just like you, my friend. You've been programmed.
Right. Well, I tell you what, it's been an absolute pleasure having you on, Dave. Do you have any final words?
Final word is
before you get away.
Go to flatearthdave.com.
Your website, please.
Flatearthdave.com. Just go. I have an app. The app will blow your mind. It'll save you.
What does the app? Yeah. What does the app do? I saw that on your website. What does it do?
So the app, every day there's a featured video, and I tell people is that normally the challenge is get the app. It's $3. Full disclosure. And every day, just watch the daily video for 2 weeks, and then you're toast after that. There's no way to do that and not have a million more questions and understand that you don't live on a globe. There's the frequently asked questions section. There's the images section. Just type in Southern flights and all of those flight routes that will come up, and you can see them visually. There's a homeschooling section. There's the weather map with the wind charts. There's all sorts of, there's a biblical section. There's an old world section. Have you guys looked into the old world, the lie of the old world, the technology that used to be here, the advanced civilization that was here?
I have heard of it. I have heard of it. Yes.
On my website, the banner across the top of the website, it says Old World Order. Watch it. New movie just came out. Just watch it. It's free. Just watch a video, and it'll send you down a rabbit hole that you can dive in head first, because there's no bottom. Right. And so just check out that stuff. And I guarantee, I get so many emails from people. Dave, I thought you were crazy. Absolutely. I made fun of flat earthers. I refused to look. But then I went to your website and I watched a couple of those videos. And then I watched them more. And then I got your app. And holy crap, you've ruined my life. And then they thank me. Right. And because once you see the truth, I believe that people get depressed because their soul is trying to talk to their mind, but their mind is lost in the lie vision programming, right? It's lost in this world. You guys believe in nuclear bombs? On my website, there's a banner that says,
yes, I do.
You do. So here's the thing. You can believe in nuclear bombs, believe the lie, right? Or you can go click the nuclear bombs banner, listen to the podcast there, and then make up your own mind based on new information. It's not a theory; it's a fact. But unless you see the information, you'll always just believe what you were told. And here's the thing: try to take someone's ball away from them. Take the globe away. They cry like a friggin' baby. Try to take the biggest fear that they have, nuclear bombs, away. It's worse. They'll fight you to the death to maintain that fear. But what if you knew for a fact right now that nuclear bombs were not real? Anytime you hear a politician or somebody mention the nuclear threat, you'll giggle instead of shake in fear. You'll giggle.
Well, I don't shake in
funny.
I do giggle because of just how stupid those politicians are by the way they talk about it, because they know nothing about it. But for somebody that actually does know about them, and somebody that's, I'll just say that I'm not going to dispute what I've seen with my own eyes. Okay, that's all I'm going to say.
Well, you have to, but you can see things and be fooled. There's never been a time where plants, animals, and people didn't live and thrive in Hiroshima and Nagasaki, right? There 3 days after the nuclear bombs went off, the trains were open, the sandwich shops were open, they're selling flowers on the street, everybody was back to work, right? That doesn't sound like a nuclear bomb.
It took quite a while for most of them to die. They didn't.
3 days later, there was no radiation.
It took a long time.
Where are you getting your information from? Here's the thing. We can go another 5 hours and I can talk about nuclear bombs. Just listen to those videos and then you'll know. But here's the thing. Most people won't go and look because they'd rather keep their own belief because it's easier. You want to be rich? I'll tell you how to become rich. Invent something that makes people lazier, right? Because people want to be lazier. Hey, fast food. You don't have to shop. You don't have to cook. Hey, DoorDash. You don't even have to go and pick it up. They'll bring it to your door. You don't even have to get off the couch because they'll walk in your house and hand it to you, right? People want to be lazy.
You're preaching to the choir, brother. You really are. Especially with Johnny. Johnny is the absolute antithesis of a DoorDash, fast food kind of guy.
Yeah.
We all believe the same things that you're given as a reason why we're told it's a globe,
Marty.
And if it proves that you're correct,
I'm right.
and that nuclear weapons don't exist, trust me, I'd be getting the boys together and heading east straight away.
Go to my website. Go to my website. Scroll down till you see the big nuclear bomb hoax, and then listen to the podcast. They're audio podcasts, so you can plug in your earphones, go for a walk, do something, and listen and think and use your own mind to say, is this information I'm hearing real? And then go verify everything. It's all verifiable. All right, check that out, and then start there. Maybe that'll bring you to flat Earth. I'm not sure. Marty, good luck, my friend. You got a long way to go.
It's
Johnny,
been a pleasure,
you're
an
halfway
absolute
there.
pleasure.
Dave, it has been a pleasure having you on, and I hope that in due time, well, maybe 6 months or so, or maybe next year or something, we can have you back on, because it's an absolute pleasure, and I'd like to have you back at some point. So I'd like to keep that door open.
Yeah, no worries, man. All right, thanks.